Hello and welcome back. Time for lesson 4. We're going to learn about calculating or computing the present value. Let's have a look. Sometimes we know the maturity value, but we don't know how much we should invest to get there. So for example, I might want to have $5,000 available next summer for a trip I'm planning to take, and I know what kind of interest rate I can earn and how long until my trip is going to happen. And what I want to do is calculate how much I should put in the bank today in order for it to grow to become the amount I need. So in this case, we're going to rearrange our maturity formula to solve for the original principal, or for P. We can come up with a formula for present value by rearranging the terms from a formula we already have for maturity value. So that's the one we've just been working with. If I were to divide both sides by that whole term in brackets, I would have P is equal to S over 1 plus RT. So I divided it down to this side, and then I flipped it left to right. So P would be over on the left. That's fine if you want to leave it in that form for now. An even better way to write that, though, is to write it as P is equal to S times 1 plus RT to the power of negative 1. That's the same thing. Anything to the power of negative 1 is the same thing as 1 over that number. So we can do that with the term in brackets as well. And that gives us a new formula we can use for present value. Let's have a look. Here's an example. Erin invested some money into an account earning 6% simple interest for 180 days. At the end of the term, she had $6,000 in her account. Can we calculate the original investment amount? Well, let's just go through here and write down some of the things we know here. She ends up with $6,000. She earned a rate of 6%, and her investment was in there for 180 days. Again, I'll convert that to years because the rate was per annum as well. And we want to find the original investment amount. Let's pull out our formula here. S times 1 plus RT to the power of negative 1. By the way, here's a tip for you on your calculator. You can quickly do the negative 1 exponent by using the 1 over x button. And you'll find that button located just 2 up from the 9 key on your calculator. So if you do 1 plus RT, everything in brackets, press equals, and then go press this button, it'll raise it to the power of negative 1. Then you can go and multiply it by S. All right. So let's have a look. Let's put some numbers in here. 6,000 times 1 plus 0.06 times 180 over 365. If you're doing these and you're having a little bit of trouble, don't forget BEDMAS, multiply before you add the 1. Maybe that's part of what's going on. All right. If we were to calculate this out, and if you work it out correctly, you'll end up with a smaller number, because that would make sense. It would take less money at the beginning in order for it to grow to 6,000. In this case, $5,827.57. So if Erin puts $5,827 in the bank, it'll turn into $6,000 later on. All right. What we're really doing in this case here is we're saying we want to have $6,000 in 180 days. How much should we put in at the beginning to make that work? And we're using a rate of 6% to figure this one out. So it's if you think about a little timeline again, this time we're going backwards to the left. That's part of the reason, by the way, that I like this negative 1 exponent, because when I'm moving backwards to the left like this, it reminds me the negative 1 kind of matches when I'm going backwards. All right. Let's give you a chance to have a look at one here. Peter's considered buying an investment that promises to pay $10,000 in 9 months. So basically, he's got a deal here. They've got a guaranteed payout for him in 9 months. He's going to offer them some money for it now, but probably a little bit less than the $10,000, because that way he can make something over his 9 months. He wants to earn 10% overall as an investment rate. So can we use that to work backwards and figure out the price he'd be willing to pay today for the investment? Right now is a great time to press pause and just take a few minutes, see if you can work it out. And when you're ready, come on back and press play and we'll have a look. All right, so let's have a look. Peter wants to end up with $10,000, or that's what he's going to get, in 9 months. So I'll convert that to years by dividing by 12. And he wants to earn an annual rate of 10%. How much would he be willing to pay at the beginning? I'm going to just quickly show you the timeline first this time. They're going to give him $10,000. Can we work backwards to figure out what it would be today, or what he'd be willing to pay today? So let's go ahead and use the formula for P. Put some numbers in there. We've got 10,000 times 1 plus R T, all raised to the power of -1. And if we work this out, can we expect a number slightly smaller than what we're going to end up with? In this case, $9,320. Sorry, $302.33. That's better. $9,302.33. So Peter would offer that today. Over the course of the next 9 months, you'll make almost $700, which if we work that out to an annualized rate of return, is exactly 10%. That's it for this little lesson. You want to practice some of course, so as you go through the textbook, make sure you do lots and you get a good handle on these. What we learned in this lesson and the previous lesson around maturity value are both going to be critical pieces for our next lesson when we try to put it all together. So take the time you need to do lots of questions and go through as many as it's going to take to get you really good at these. Success strategies, again, just like before, take your time reading the questions, write down everything that's given to you as well as the unknown, just like I always do. Make sure you're working in consistent units and use all the decimals during calculation, only round your final answer. And then make sure that you're learning how to fully use your calculator as we go. Don't forget, there is a copy of the calculator manual available on our website. But the better you get at your calculator now, the easier it's going to be for you as the problems get more interesting and more complex. All right, thanks. We'll see you next time.